Chapter 6, Day 3. So still looking at differential equations. Write a differential equation for each. The rate of change of Q with respect to T is inversely proportional to the square of T. So if you remember from Algebra 2, when you solved these, two variables were either proportional or inversely proportional, inversely related. Rate of change, that represents our derivative. So the rate of change of Q with respect to T, if two things were proportional, then we multiplied the proportionality constant. If they were inversely proportional, then we divided. So now instead of relating a function and a variable, we're relating the derivative and that variable. So inversely proportional to the square of T. The rate of change of n with respect to s is proportional to this quantity, 250 minus s. So just being able to take a word problem and write it as a differential equation. All right, we look specifically at growth and decay models. So this is the differential equation representing any growth or decay model. So this would be the rate of change of y with respect to t, and that would be our unit of time. And then here we're multiplying, so the rate of change of y with respect to t would be proportional to y, and k is what relates those two, so that's your constant of proportionality. Okay, so if we took this and I asked you to solve this differential equation for y, we would separate the variables, and this is something that we may have talked about in class. But if I want to separate the y, get the y's together, then keep k. K is just a constant, so we'll keep that on the right hand side. So when we integrate, natural log absolute value of y is equal to k times t plus c. Again, k is a constant, and we're integrating it with respect to t. So then solving this equation, y equals ce to the kt. Alright, so we discussed this in class, being able to go right from this step to solving the equation for y. So the solution to that differential equation is your exponential growth and decay model. And again, going back to Algebra 2 and pre-calc, when something was changing continuously or being compounded continuously, perhaps your Pert formula should look familiar, where P, in this case, what we now call C, that's our initial value, K is the proportionality constant, and then depending on the value of K, it would represent growth or decay. And then T is our unit of time. So what does this represent? This is the solution to the differential equation, K times Y. So let's solve the warm-up equations. dq over dt inversely proportional to the square of t. Separating the variables, and now we'll integrate both sides of the equation. Q equals k t to the negative 1 all over negative 1. And then given some initial condition, we would be able to solve for C if need be. Rate of change of n with respect to s is proportional to this quantity. separate the variables. When we go to integrate both sides, k is just a constant, so we can bring that out if needed. So 250s minus s squared over 2 plus c. Now, of course, if this is a word problem, we would define what n and s represented, but this would be the solution. Now, another way we could solve that, if you think of 250 minus s as that entire quantity, we could set up a u substitution to be 250 minus s. du would be negative 1 ds. So we need a negative out front. U squared over 2 plus c, and then replacing u plus c. These are equivalent equations, and either one would be correct if you were asked to solve that differential equation. Alright, so now writing a function. Find this, it would be exponential growth or decay, given 2 points. You also did this in Algebra 2, so the question would have asked, fit an exponential model to these 2 points. Those of you that took FST, you did an entire chapter on this. Okay, so points give us values for x and y. So what can we do? Plug them into that exponential model. 1 equals CE to the k, and in this case, it should be t and not x. And then plugging the other function in, 5 equals CE to the 5t. Alright, so for those of you that took FST, sorry guys, that would be 5k. Stack the functions on top of each other and now divide them. 5 divided by 1 is 5. The c's cancel. Dividing like bases, we subtract exponents. Now if we wanted to solve that for k, take the natural log of both sides. We get ln of 5 equals 4k, and then solving for k. Alright, so now once we have k, you have to plug in to solve for c. And I'll approximate this decimal. So now from here, once you have the value of k, plug it into either of the functions. And solving this for c, and for the classwork today, you do get calculator practice for that. So to solve for c, we would just divide both sides by e to that power. Alright, so for next class, complete on page 420, numbers 17 to 20. Make sure you read the directions, but you do not need to graph the solution. Have a nice day.